today we're going to be learning about hash maps inside of Java. Now, a quick note before we start the video. If you haven't learned about array lists beforehand, then I suggest doing so. If you haven't, then you can look in the description below and you'll see a link to the array list tutorial by SAPP coding tutorials. And if you've learned it elsewhere, then that should be just fine. We're going to be referencing a couple things from hash maps, from array lists. So if you aren't aware, or if you're not too familiar with array lists, then I definitely suggest reading up on them or something, because the knowledge will definitely be of use here. Okay, so let's get into it. So how do we define a hash map really? What is it? So a hash map is a type of data structure, which is basically like a tool in programming that we can use to store and retrieve data easily in large amounts too. Unlike the array list, however, which is also a data structure that does the same thing, hash maps aren't lists. So obviously, if you've been paying attention to the naming here, you would have noticed that an array list is a list and a hash map is a map. Now, they both store and manage data, but they do so in kind of different ways. So the difference here is that array lists use a system called the index system or something. I don't know what it's officially called, but all it does is every time you add a value to the array list or a list, it will store the value, but it'll assign an index to it. So that means that what you need to do if you want to retrieve it is every time you want to access that value, you need to use its index. So you can say like ArrayList.get and then like the index number, and then it'll retrieve the index for you, right? So that's pretty self-explanatory. That was, if you haven't, like I said, if you aren't too familiar with that concept, definitely go up and read about it. This isn't an array list tutorial, this is a hash map tutorial. So we're not going to dive too deep into this index system thing. But yeah, if you haven't heard of it, definitely go read up on it. Anyway, so a hash map, or maps rather, work a little differently than lists. So instead of adding elements to a list, because like imagine you have like a grocery, like a shopping cart, or maybe like a groceries list, you can add items to it, right? Like maybe eggs, milk, bananas, I don't know. And then for the cart, you can add like items from the shop. Yeah, you can add those to the end of the list. And you know that the latest item is always the last item usually, because you start at the top and then you keep going and then eventually make your way to the bottom. However, maps are a little different. They're not like that. So you have a map. Just imagine a normal map, like a piece of paper that has like locations on it and you can, navigate through a city or something. Yeah, that kind of map. On that map, you should be able to mark certain positions. Like if you're like imagine you're trying to make your own map here. Kind of like how if you make your own list, you're making your own map. And you want to note down where, like, for example, a local bakery is. Yeah, you would put it on the map, right? You wouldn't add it. I mean, you can add it to the map, but I mean, I guess you're putting it on the map, I guess. And you'll see why I'm using that. I'm trying to use that terminology in a second. So when you put it on the map, then you need to have two key pieces of information. One, you need to note down what exactly you're putting on the map, because if you just put like a dot, then no one really knows what that dot's supposed to be. You need to kind of say what it is. So either through an illustration or maybe like some text next to it. And then the second thing is the location of it. So in hash maps, you need to actually list down you need to note down kind of like a location on the map. Like where on the map is it really? Because, with a visual example, you can tell where it is, but this is a data structure, right? It's just text in a text editor. Like literally, you're not really drawing it anywhere, so you need to state where you're putting it. So that's kind of how it works. So because it works that way, since you're actually saying exactly where you're putting it, it actually doesn't save the order. Hash maps don't pay attention to the order in which you add them, add the elements that is. So they tend to get lost or jumbled in the memory. So you can't really rely on orders. And that also means you can't use a normal for loop to just loop through it and get the elements that way, because it doesn't use the index thing. So you can't do that. So they rely on the exact position of each item. So you have to specify each item on the map, where exactly it is, and then you'll be fine. But what is that called? Because I've been using pretty ambiguous terms here because I don't want to introduce confusing terms. And, in order to make those terms less confusing, I'll introduce them now. So we call these key value pairs. So what exactly are key value pairs? Basically, this is what the hash map uses as an alternative to the index thing. It doesn't use indices. So instead, they utilize this key value pairing system. So what that means is that for every value that you add to the list, you have to assign it some kind of key. And what this key is basically the location on the map. So if I say bottom left, then the key would be bottom left. I mean, obviously not literally, but I mean, it's as if. Now, the reason why it's not literal positions is because a hash map isn't actually like a legit map. It's like a thing it's like a thing in memory that stores data. So obviously they decided to make it a little more practical, and you can store anything you want here, any data type. So you can store any data type for the value and any data type for the key. There are many other uses for them too. You just need experience. So, practice with these all the time, and then you'll be fine. So when you assign it, okay, so one good analogy that I like to use for key value pairs is, rather than also like the map where like you have to specify the location, it's also like a locker. So if the hash map is like a locker room, each value is locked up in a locker, and in order to access that locker, you need to use the key. So each value has a specific key. No two values can share a key. One of them will overshadow or override the other, and the other one will be kind of, lost in the shadows. So if you have two with like a key number, like let's say you have 10 as a key for some reason, and you have two values that share that key, only one of them will ever really be seen by the hash map. Like, it'll just forget about the other one. So be a little careful with that. It won't give you an error or anything either. But one important thing is to make sure you assign meaningful keys. If you don't assign meaningful keys, then that kind of ruins the whole point of the hash map, because the whole part of it being like so so intuitive and stuff is because you can assign your own keys. So that means that you can assign meaningful keys. So yeah, so it makes it really efficient to retrieve if necessary. And I said there would be an example at the end. I'm actually just gonna save that for the coding example, not this video. So okay, so similar to the array list, the hash map features 4 main functions. Now it has a whole list of other methods and stuff, but we're not going to talk about all of them. We just want to focus on the 4 main ones that allow us to, add stuff to the hash map, remove stuff from the hash map, and just regularly get stuff from the hash map so we can kind of access that data and set stuff up. So these are kind of just the 4 that the array list featured as well, but they're a little different. We'll talk about how in a bit. And then there's also the size method. This one is the same actually, so I might not even cover it that much. It just returns how many key value pairs or how many elements are on the map. Okay, so the 4 functions are as follows. We have the put method, the get method, the remove method, and the replace method. So let's talk about them. The put method. So it takes in a key and a value, which is of, type key and type value, whichever one you specified. So this could be a string, and this could be like an int, or this could be a string, and this could be an int. You put whatever you want. Like maybe Boolean for some reason, if for value, I don't know. So the point is, this will put the thing on the map. This method will put your value on the map at location key. So, and that is exactly what I wrote actually. So yeah. So, and here's my locker room analogy. You can think of this as putting the value in a locker, and the only way to retrieve it is by using this key. Next is the get method. This is how you actually retrieve it from the map. This is kind of like reading the map. If you have a map, then this is like going on the map and going like, okay, let's find a key, and then they find location key, and they just get whatever is there. So that's pretty easy. It just returns the value that is paired with this key. Remove is like the same pretty much. You feed in a key, and it'll remove the key value pair from the hash map. So, that's good. And replace will simply, it'll say, basically what you do is you specify a key and a value, and it'll check to see if key is paired with another value. And if so, it'll just kick that value out and replace it with this value, and then the other one will be returned, which I forgot to specify, but okay. One important thing about get though is if you try to say get a key that doesn't exist, you actually won't get an error. Rather, the method will return null. So if let's say I have lots of strings in there, but I say but let's say pencil is not one of the strings I have as a key, but I say get pencil, nothing will happen. It'll just return null. So you can rest assured that like you won't get any errors. You will get errors though if you try to directly operate on it though. Like if you say get like pencil and then like dot contains or something, like it's a string I guess, then you're gonna get an error because it's gonna say no operations on null or whatever, null pointer exception. So yeah, that's not the point though. Point is that we have something to add, something to retrieve, something we can use to add, something we can use to retrieve, something we can use to remove, and something we can use to replace. If you got these 4 down, then I mean you can use a hash map pretty well. I'm not going to say a fully functioning hash map or a hash map to its greatest ability. There are a couple other methods I would recommend you learn for that. And we will actually talk about a couple of the other methods at a later point in time when we talk about, or in a future lesson when we talk about a future thing. But, we'll get to that when we get to it. Okay, so that's the end of this video. I hope you learned something about hash maps today. And in the next video, which I will link in the description below, we will code with hash maps. So we'll just kind of mess around. We'll create a hash map and we'll kind of add some values to it, and then we'll mess around, kind of like what we did with the array list. if you have any questions, comments, or concerns, leave them in the comment section below. So yeah, I hope I see you guys in the coding video. Obviously, if you feel like you got HashMaps, if you feel like you got what you were looking for, then you don't need to check that video out. But if you feel like you want to kind of see it in action, then I mean, feel free to join us. So yeah, that'll be it for this video, and I'll see you guys in the next one. Goodbye.